Fantastic. So, like I said, what I want to focus on is just what is ADAS and how does it fit into the market and who is the right customer for the ADAS system. So, there's many different ways to pronounce it. I pronounce it ADAS, ADAS. Some people call it ADAS. Some people call it other stuff. So, I've always just gone by ADAS.
Okay.
So ADAS stands for Advanced Driver Assistance Systems, and they're designed to increase the safety and reduce accidents. And these are not new to the industry by any means. We've seen these in cars back as far as 1998. And basically what has happened is the insurance industry has started seeing a great result of lower collisions and lower fatalities with these systems in place. So the collision industry or the insurance industry has really pushed on the government regulations and industry to be able to put more and more ADAS into the world. And there's multiple different levels of ADAS. Some are fully autonomous driving cars, like we think of it with Tesla, and then some are very limited. We were actually at a show, and we needed a vehicle with ADAS to put in the booth. And the vehicle we chose was very high end. We went with a premium model. We went with a Toyota Yaris. And if you think of a Toyota Yaris, you don't usually think of a premium line vehicle, but it did have ADAS on it from the factory. So we were able to use that in the booth to display it. So it's all about assisting the driver. This is, it's considered an assistance system. It's not considered a safety system like ABS. And the big difference between the two is I can turn ADAS off. I can turn every piece of it off. Where if I'm talking about ABS or traction control and a lot of those things, I can't turn those off. I can't turn off airbags in the driver's seat. That is a safety system. So these are considered an assistance system. So there are two different types of ADAS systems. The first is a passive system. A passive system just lets you know that you're a horrible driver. It lets you know by flashing a light, buzzing your seat, making a dinging noise. It won't actually take over the car. It only tells you that you have something that you need to pay attention to. So a passive system monitors the conditions around the vehicle and warns the driver via lights, messages, audible tones, vibrations, steering wheel, brake pedal, and so on. But like I said, it doesn't actually take control of any of those. So I've been in a lot of vehicles where it buzzes the seat. And if you have someone in your blind spot and you put your turn signal on, it will vibrate that side of the seat saying, warning, warning, there's somebody here, don't go there. So that is a passive system. And then we have our active systems. So the active systems are the ones that not only tell you you're a horrible driver, but they also take control of your car because you are a horrible driver. So these are the systems that will actually slow down your car. It will push you back into your lane. It will do the adaptive cruise control. If you're getting too close to somebody, it will slow you down. It will apply the brakes via the ABS module. And if we think about all the different systems that a vehicle takes to be able to operate ADAS, we're talking not only the power steering module, but we're talking electric brakes, we're talking the ABS, we're talking throttle control, PCM, and much more. All these systems have to communicate with each other for the system to work properly. And if there's any communication errors or one of these systems is not functioning properly, it can throw the whole thing off. I've actually had some vehicles that if you have a TPMS light on because your tire is low, it will also set the traction control and ABS light on because it can't control the vehicle if you get into an off camber or into a yaw rate position. So when you shut down the ABS and the traction control, you also shut down your ADAS system. So something as simple as a sensor in your tire measuring your tire pressure can shut the whole system down. So we talk about some of the different pieces and parts that go with ADAS and what we have to have on these vehicles. And this is just some of them. These are just a few of the systems and their types. And these are lane departure warning, blind spot detection. So whenever someone's coming up beside you, you can't see them, your car will notify you. Rear collision warning. And that is if you're backing out of a parking spot and someone is coming, you can't see them, it will actually apply the brakes and stop that vehicle for you. A round view is the 360-degree camera. When you put it in reverse, it shows all the way around the vehicle. Night vision is on our higher end vehicles. A lot of Volkswagens, Mercedes, Cadillacs do night vision, where it'll actually display on a heads-up display showing if there's anything that gives off a heat signature like a deer or an animal or a bear or something along those lines. Those are all passive systems, but they're also included as important pieces of the active system. But the active system adds these others like adaptive cruise control, lane keep assist, adaptive front lighting. Adaptive front lighting is where your brights automatically turn on or automatically turn off as you're going down the road. And then front collision avoidance and much more.
One quick thing, Chad. I did a little research into ADAS. So there's I think there's some sort of, correct me if I'm wrong, there's some sort of, they standardize these things in terms of 0 through 5, correct me if I'm wrong, in terms of how much control the vehicle takes over. You know, for example, on a 0, right, it might be just airbags, right? They don't do anything to help anybody, whereas something on a 5, whereas a 1 might, you know, offer a buzz or a vibration, but if you go all the way up to a 5, that's when the vehicle actually starts taking over full control. But something like a 5 is like AI. It's like autonomous driving. It'll take over everything.
Yep. Yeah, and it's arguable if we are at a level 5.
That's right. That's
right. The Teslas and some of the higher end Volkswagens and such that are trying to do it, they consider themselves level 4, where they're highly autonomous. And then you go all the way down to 0, which is no automation whatsoever, just normal safety systems. You are correct. So when we look at some of these things that we have on the screen, the passive and active systems, it takes sensors on that car to be able to control that and to see that, because a car doesn't have the same style of vision and the same style of processing that we can do on a human level. So we look here on the left, these are short, mid, and long range radar. These are all radar sensors. And a radar sensor is just like we think of a normal radar in a submarine. It's sending a signal out, it's bouncing off and sending that signal back. But we have to have different radars for different ranges. We have to have a long-range radar, and that is used in adaptive cruise control to know if we are approaching or getting closer to somebody. We have to have that mid-range that is going to be for adaptive cruise control and for collision avoidance. And then we have to have that short range, which is going to be for like our parking sensors, if we're getting really close to a wall or a parking stop or something along those lines. So a fun story of a customer that had come into a shop, a little old lady had a Cadillac. And she comes in and she says, my Cadillac, my car is possessed. Okay, well, ma'am, what do you mean by that? And she says, well, I'll just be driving down the road. I got the cruise control on, just cruising down the highway. And all of a sudden, the car will just slam on the brakes right in the middle of the road. It just jams on the brakes. So the technician in the shop takes this car and goes for a drive and does exactly the same thing this lady says, gets on the highway, puts the cruise control on, nobody around, and all of a sudden the car just freaks out and slams on the brakes right in the middle of the highway. So they bring it in, and what they found out was the short range sensor, this one down here on the bottom, is mounted very low in the car. Like, it actually sticks out past the fascia on the bumper. And this lady had hit the curb, and when she did that, it bent that sensor up. So that sensor is going around looking for airplanes because it's facing up at the sky. It's not facing the direction it's supposed to. And then all of a sudden it sees a bird and just freaks out and it jams the brakes on the car. So these sensors have to be calibrated. They have to be facing the right direction, not only forward, but they also have to be the right level. Because if we are just a couple degrees off, up or down, at 20 yards, that's a pretty huge change. The ones right here in the middle, those are stereoscopic cameras. Those are usually mounted behind the windshield or where the rearview mirror is. Ultrasonic sensors, these are in your bumpers and also in your blind spot warning. So in the rear bumpers, those can see through bumpers and see cars that are coming by you. And then LiDAR, which is a laser rangefinder, basically. can sense distance, so it can tell how far away that car is from you. So when we look at these sensors, we can see where these sensors are located on the car. So if we look right here on the windshield, you can see that there's a black area, and then you got little windows in there. Well, those are for either LiDAR or that forward-facing camera. Those forward-facing cameras see the lines on the road, and that's what helps you stay in the middle of the road. If you look at the side mirror, you can see a camera in there, and that is for our around view monitor. So that's our 360-degree camera. If a car is in a parking lot and they break your side mirror, you have to replace the mirror, which is $400 to $500, and then you have to calibrate it. If you don't calibrate it, your around view monitor won't be lined up properly, and it'll make everything look really funky. If you look right here under the hood, that is our either our long range or medium range radar sensor. And that is right up there in the front where every technician puts their hand when they're trying to get into the engine bay. So that thing can bend down pretty easy. Located in the bumper, the tailgate, rear collision avoidance camera. Behind the grill is another radar sensor that's on a Toyota. And these are on a Volkswagen and Audi. These are also radar sensors. And sometimes they put night vision down there as well. So we got sensors all over the car now. And these sensors, anytime they're disturbed or their environment changes, we have to do a calibration on them. So if we do an air conditioning service on a Mini Cooper, for instance, you have to remove that front bumper cover. And when you remove that front bumper cover, now all of a sudden you have to recalibrate that sensor. If we replace the glass in a vehicle, we have to recalibrate that sensor now because we changed the lens on that camera. So when is a calibration required? Well, the OE has very specific requirements for that, but generalization after a collision, after the hood or trunk is removed or replaced, if the front bumper or rear bumper is removed, windshield, mirror replacements. And this is where people get confused, is on suspension rework or alignment, because everything that we do focuses on the center line of that car. And if we change the alignment to that car, now we change the center line. So we have to align the car, and then we have to do ADAS calibration after that. If people curb their car, like that bumper sensor I was telling you about, or even if a module is replaced. Remember, I talked about all those different systems that use ADAS, and if one of those is replaced, then we have to recalibrate a whole bunch of different systems inside that car.
Question, Chad.
Sure.
This is, I guess, this is maybe an easy question or a dumb question, but so if any of these things do happen, you get your something happens, or you replace your bumper, etc., with the hood, windshield. Will your ADAS system tell you that something is off and this needs attention? The ADAS system, it needs to be recalibrated.
Very unlikely will it. The only time it will is if it is broken, or if it doesn't have a signal going to it, because it doesn't know it's out of alignment.
Wow.
It doesn't know it's looking at airplanes.
Wow.
So very rarely will a system tell you. And that's one of the big struggles in the industry is, how do we know when to if the car doesn't tell us?
Wow. Yeah. Another related question might be, so I'm fairly new to ADAS, but I've heard of this term before. When cars are marketed, when cars are bought and sold, to my knowledge, ADAS, what it is, it's just a collection of systems, right? It's a group of systems, right? That's what it is. But is there some sort of umbrella standard or something where is ADAS like a standard? Maybe not. Like for example, if I were to go shopping for cars, this car has ADAS. This car does not have ADAS. They don't really say that, right? Or do they?
No. So if you're shopping for cars, the car itself will not say ADAS equipment. ADAS is a general term in the industry. It will tell you that it has adaptive cruise control. It will tell you that it has rear collision avoidance around the monitor.
What's interesting, yeah. Go
They're,
ahead.
the only thing right now, as of 2021, that is standardized, that is required by the U.S. government, is rear collision. I wouldn't even say avoidance, rear collision notification. So it had, I think they require you to have a camera on the back of the car. That way you can't back into kids, is really what it comes down to, that safety aspect. And that's the only one that's required. Everything else is voluntary based on the manufacturer and what they want to offer. I can have two identical Toyota Corollas next to each other, and one will have all the ADAS systems and one will only have a couple, and then the next one will have none. There's not a standardization by badge, by XL or XLR or SLT or anything like that. There's no standardization across that. So it just kind of comes and goes, whatever that manufacturer felt like on that day.
But I suppose on these individual passive and active systems, on the individual basis, you could probably, they may not tell you whether they're malfunctioning, but you can probably figure it out, right? Something's going on, right?
Well, hopefully, yes. So if you're an astute driver, a lot of times you can figure out, this doesn't feel the same way it used to. I need to take this in.
Or the rear camera doesn't work, stuff like that, simply.
Well, yeah. Or so on my wife's van, it was, I would have the lane keep assist on, and just because I like to just take my hands off the wheel and see what happens. And I noticed that it would go over the outside line before it would correct itself and bring it back in. And when it would bring itself back in, it always cheated to the right-hand side. So I knew that my cameras weren't calibrated because I'm supposed to be in the center.
Yeah,
so I ran it through a calibration cycle, and it fixed it, and now it's centered itself. So now it goes in the road in the middle where it's supposed to be.
Got it. Thank you very much.
But a normal person probably wouldn't notice that, unless they were researching it or looking for that. So it's our job in this industry to really educate those customers as well. We need to let them know that, hey, these systems exist and they need to be calibrated after these type of things. Because when we go into a shop and we talk to a shop about ADAS, your high-level shops are going to go, yeah, I know exactly what you're talking about. I do have to take cars to the dealership because I don't have the equipment, da-da-da. If you go into a ding-dong dirt floor shop and you ask them what are they doing for ADAS calibration, they're going to look at you like you just spoke Greek to them. They have no idea what you're talking about. They can be an alignment shop and a tire shop, and they have no idea. So it's still very much an education game when it comes to ADAS.
Okay.
So I have a question as well. So I've been asked the product manager in China. Also, I used to talk with the technician in China as well. So before we have this kind of calibration tools for ADAS, what technicians do to calibrate for this kind of problem?
Take it to the dealer.
Take it to the dealer.
Because a lot of those tools were specialized, and a technician could not do it because they had no access to those calibrations.
Let me give you an example. Okay, so in China, most of the car is not occupied full feature as the dealer advertising. So a lot of DIY. So in China they do like add-on component after they purchase the car. So what I see, some of the garage or workshop to do this kind of DIY job, they draw the paper and put the ground of some background on the ground, do the 360 things. So I used to ask them, when you guys don't have this kind of ADAS tools, what do you guys do the calibration? And I have my Mercedes E-Class 2 years ago facing the same problem because my wife have a small accident, make the front camera not in the correct position. So the alert keep come out on the dashboard. So I take to my friend, and we don't have ADAS tools yet. So what he do is he use the dealer tools. In China it's a C4 or C5, and they said that once they do the manual calibration of the camera. They need to do the road testing, let the vehicle learn by self. So what I understand is they can do learn by self, or you can use this tool to do the more efficient way, directly calibrate. You don't need to learn by vehicle.
So I'm gonna cover that. That's called static and dynamic calibration. Okay. So yes. So one of the things you mentioned about they drew their own targets. Before ADAS really became a big thing, we saw that at the dealer. So Toyota, for example, you go onto their OE information and you can print a target out, and it's just a box, like a 4x4 box, 2 black ones, 2 white ones, and then they would take it and they would tape it to a broomstick, and then they would go forward and then back until it calibrated, and then they call it good. Okay. Now we try and have a little bit more precision to that because it is considered something that could save your life. So we try and have a little bit more precision in that. But yes, you're talking about 2 separate systems, and I'm going to cover that here in just a second. So a lot of that comes back to how many vehicles have ADAS, and how likely are we as technicians, or how likely are our shops to see this? Well, it's becoming more and more popular, and it's actually mandated now on some vehicles. But we see this with ABS and electronic brake systems in the modules and speed sensors. It uses electronic power steering. It uses the throttle position sensor control, cruise control, throttle by wire, and vibration and pulse complaints. And these are all maybe ADAS related. So when we look at the customers, who's the customer base that we're going after for these tools? We're going after body and collision shops for sure. This is the biggest thing for body and collision shops. Windshield and glass replacement is really where the mobile units were designed for, because they're portable and they focus on that lane departure warning. Alignment and suspension shops, general repair, we're getting less and less because there's not a whole lot of general repairs left. They either do it or they don't. So there's kind of an in-between there. Dealerships, this is very funny because a lot of this is not required tooling for a dealership. So I'm going to my GM dealer probably next week, and I'm going to load up my ADAS system in my truck and show it to them because they don't have one. My dealer does not have an ADAS system, and they replace glass. So they've not been doing it. What they tell me is that as long as they don't unplug the camera, it doesn't have to be recalibrated. I'm like, what do you mean? So I asked the guy, I said, so you're telling me that the glass you put in is in the exact same place as the factory one? Exactly. Nothing changed. Well, it's close. Well, close doesn't count at 100 yards when you can't stop your car anymore. So dealerships, rental car fleets. I worked a lot with Avis and Enterprise Rental Car at my previous employer, and then large municipalities that own a lot of vehicle fleets. So anybody that has a lot of vehicles or a lot of volume. All right, so what do I need? What do I need to be able to do ADAS calibration? We need to have a diagnostic tool because we need to tell the car to go through that diagnostic process to calibrate itself. So here's another thing that the industry really struggled with at the beginning is they said, well, I have to use an OE tool. I have to use GM's original tool. I have to use Mercedes' original tool because an aftermarket tool cannot possibly calibrate the same as an original equipment tool. Well, here's the dirty little secret. The tool itself doesn't do anything. The only thing our tool does is it tells the car to do its calibration process. All of the calibration process is built into the car itself. All we do is tell it to go. So that takes all the liability off us and it puts it back on the car. So a complete diagnostic tool. We need to have various calibration fixtures and targets because no manufacturer uses the same targets. We have to have an information source. We need to know where to put the targets to be able to calibrate these cars. And we need to have an adequate workspace to be able to do it. Because some cars, especially doing a round view, take a tremendous amount of space. Ford, for instance, the mats that go beside the truck are 32 feet long and 4 foot wide. So now we automatically know we need at least 32 feet plus long, plus we need to be probably about 20 plus feet wide, if not more, of clear open span to be able to do that kind of vehicle.
I'm sorry, Chad, can you please go over information sources for procedures? What does that mean again, please?
So information sources and procedures. So we need to know where to put the targets, how high to put the target, how far away from the vehicle to put the target, and how to measure where we're putting that target.
Okay.
Because for an example,
yes.
The reason I point that out is because on the original equipment tools, they don't do that. You have to go into their resource and search for that and then print that out and then go and take that. Whereas our tools give you all that information directly from the tool. So there's no hunting or searching. Snap-on you have to use a separate app. And some of our other competitors, you have to use a separate app to be able to find that information. So this is all built into the tool on our side.
Some of these things, I mean, so the broad information source for procedures. Some of the ADAS equipment I've seen on the market, some of them are very, you know, they use like pieces of paper, and is this what all of this refers to? It can refer to these things, right? Pieces of paper to align lasers and stuff like that. Is that
well? So that stuff is part of the setup process. But yes,
yes.
The information source and procedure is going to tell you to take a string and put it underneath the car and snap a straight line with that string. So that's the procedure for that OE vehicle. Whenever we look at ADAS, we talked about alignment shops just a little bit, and a lot of people will associate ADAS and alignment together, and they are tied together, but they're not one and the same. So ADAS alignment are two separate operations, and they're not done by the same machine. However, we do have some companies that are trying to get to that point where they are trying to include the ADAS and alignment into one. So that's actually coming closer as we speak. So ADAS and alignment do share a lot, though, as far as the relationship goes, because our ADAS goes off of the thrust angle of the car, the center line of the car. So an alignment is going to make that car go down the road perfectly straight. And ADAS is going to go off of that as well. So if our car is going dogleg, sideways down the road, that means that our ADAS is not looking forward, it's looking off to the side. So alignment and ADAS do work together in that aspect. And what we're actually seeing is, like on a Nissan, for instance, if you do an alignment on a Nissan, it requires you to do an ADAS calibration after that alignment. I would say the majority of the manufacturers are now going that direction. Once you do an alignment, ADAS calibration is required after that. There are some alignment machine manufacturers that have incorporated ADAS into their alignment machines. And basically all it does is it uses the heads of the alignment machine to center and square that target in front of the vehicle, and then they can do that calibration. They have not done a good job of closing that gap. They're still trying to figure that piece out. Hunter and Bosch would be a good example of that. They haven't quite put that together. Autel and Chem are doing a collaboration where those two kind of are trying to be put together. So that is something that the industry is working on, but they're not quite there yet. So we talked about space. How much space is needed? Well, this is actually pulled from Volkswagen. Volkswagen's requirements for a round view monitor calibration. So they're saying that you need to have, this is 30 feet by, I think if you add that up, it's like 20 feet. So a 30 by 20, 30 by 40 is usually the safe space. But you can see that you have the car here in the center, and then you have targets all the way around it, plus you need area to be able to walk and move around it. Yes. So you can't have a too tight of a space. And this space has to be flat and no obstructions at the same time. It can't have a whole bunch of deviations to it.
And the floor probably has to be level, correct? Perfectly level?
Yep. The OE says that you can have a, I think it's like a ½ inch over 10 feet or something crazy like that. It's pretty darn close to being level, yes. The next question we always got was, can you do ADAS calibration on an alignment bay? And the answer is kind of, sort of, maybe, and yes. The reason it's kind of, sort of, is because it depends on what kind of alignment rack you have. If you have an alignment rack with 4 posts sticking up, no, you can't do that, because the posts get in the way of the cameras, and the camera will see that, so you can't calibrate. If your alignment bay is a scissor style, that's good, but some of those scissor styles sit too high off the ground. So now we have a 12 inches of lift plus an SUV. So now we're too tall, and the calibration frame can't go that tall to be able to do that calibration. So I don't like encouraging people to do that, because most of the time they don't have enough room in front of the car anyway to be able to do that. And they can only do lane departure warning. So I usually encourage people just to have a clear open space so they don't have to deal with that.
That must be, for most mom and pop shops, yeah, that must be a serious issue, because that's the space that they have. There's some sort of bay or lift equipment that the cars are always on.
It's usually a deal breaker. It's a deal breaker for a lot of companies that say, I can't do ADAS now because of that. Yeah. And on that same note, we can't do ADAS outside because our targets are black and white. And if you're outside in the sun and you have a cloud come over and it does shadows, you're causing issues. So it has to be done in a controlled environment. So yeah, that's a deal breaker for a lot of people.
It's very tough.
So when we look at the Topdon tools and we look at how this process works, we actually give the step-by-step guidance on the tool itself. So we're going to tell you how to find the center line of that vehicle, what products and procedures you're going to need to be able to do that center line. It's going to show you how to find the center line via the plumb bob. All that's directly on the tool. This makes it very nice for the customer, for the end user, because they don't have to search for anything else. They don't have to go find a user manual. They don't have to find anything special. It's automatically right there on that tool. Okay, so this is what you were talking about earlier, Harry. There are 2 types of calibrations. There's a static calibration and a dynamic calibration. So a static calibration, as described, it's stationary. You're static in one place. A static calibration uses a target that is placed in front or around the vehicle to be able to do that calibration. And it uses specific targets for different manufacturers, and those specific targets are used at different distances from that vehicle or from that sensor. The second version is dynamic. So a dynamic means that I need to go drive the vehicle, and then when you drive the vehicle, it will self-calibrate. Now, some manufacturers, you have to know what that driving cycle is. On some manufacturers, it says you need to be on a clear road with very well-painted lines with objects on the side of the road. So it wants to see mailboxes, it wants to see trees, it wants to see the objects on the side of the road so it can calibrate itself. There are some manufacturers that want you to stalk other drivers. They tell you you need to get within 10 feet of the vehicle in front of you and follow them at a speed range of 40 to 54 miles per hour and follow them for a set amount of time. So each drive cycle is different per manufacturer. Now, when we look at the commonality, most of our European and Asian vehicles require static. So when you look at our targeting system, you're going to notice that there's no targets for a GM. There's no targets for a Ford when it comes to lane departure warning. Because in large, most of our domestic vehicles in the US are going to be a dynamic calibration. You're going to go drive them. However, we are starting to notice that most manufacturers are going to the static calibration. Because if you live in Canada, how many months out of the year do you actually have clear roads with well-painted lines? So we see right now Chrysler Fiat is changing their systems over to do a static calibration. And they are retrofitting that backwards. So even vehicles that are 4 or 5 years old, whenever they get an update to their system, to their PCM, it will update and add this feature to be able to do a static calibration. Some vehicles require both. If you have a Honda, it requires a static calibration and then a road test. So some vehicles require both. So when we look at the different ADAS systems in the market, there's it's become very competitive, I think is the right term, competitive over the last 2 years. So the first style that you will see is, I call it the stationary calibration frame. These are large frames that are hard to move. They're heavy. That hold the target board, and they have this large crossbar going across the front. So that large crossbar gives us the ability to be able to do calibrations much faster, because we can attach lasers to the wheels. That laser will shoot up and reflect off that target, and that gives us center. And then you turn these lasers on top of the bar, and that shoots back at our other targets, and that gives us square. So now I don't have any strings on the ground. I don't have any tape. I don't have any of that hooey going on. I can just use those lasers back and forth, boom, bada bing, 5 minutes, I'm set up to run. Some manufacturers are actually putting cameras on the end of those now. That would be like Autel and Snap-on. They have cameras on the end. And that uses alignment technology, so you don't have lasers going back and forth. You can pull that frame to get your distance, twist, and get your perfect square just from those cameras. That is only available on a stationary style frame, because you have to have that long crossbar. So there are benefits to it. There are benefits to having a stationary frame. And one of those benefits is it's a faster setup, and it's easier to center and square that target. Since it is a heavier frame, it's going to be less affected by a breeze or wind coming through. It's not just going to fall over on you, something crazy like that. It's easy to move around the shop with a low center of gravity. You don't have to worry about it falling over. And that crossbar gives us multiple positions from one bar. And that, what I mean by that is, if we think back to that Volkswagen Audi, they had a sensor on the driver's side and they have a sensor on the passenger side. There's a mirror that slides back and forth on that crossbar. It can set the frame and stop, and then that mirror can slide from side to side without having to reset a bunch of times. We can't do that on a portable frame because it doesn't have that crossbar. Now, the negatives to these are they're freaking heavy, so they're not portable by any means. You can't roll them in and out of a trailer very easy. It's just a total pain in the butt. And it takes up a lot of space in your shop. I had one of these in my shop, and I hated it because it took up so much space. My shop's not big enough. So you have to consider the space requirements. And it can't be loaded by one person. If you need to move it to a different place, it's quite a feat to get it moved around. So on the other side, we have a portable solution or a mobile solution. And the mobile solution uses a collapsible frame that's lightweight. This unit weighs 70 pounds, which is relatively lightweight, and it makes it a lot easier to transport. It folds up into a tight little package. You can pick up, put it in a van. You can pick it up, put it in the back of a truck, and it can be done by one person on the road. And we can see that the targets are very similar. They go between the two different systems to be able to calibrate these different vehicles. Now, the positive side to this style of frame is that it is very portable. It's easily moved around, easy in and out of a van. So even our glass technicians can go to a body shop, they can replace the glass, they can then do the calibration right there on property, load up their equipment, and head out the door. It folds up and takes up less room in your shop or your van, and it is expandable. You can add all the different targets and pieces to it by adding on different kits. The negative side is it doesn't have that crossbar, so it's going to take more time to set up because you do have to use lasers underneath the car. You do have to measure on the ground and put little tape marks and put little crosses. You do have to go through that whole process. And just like you see in the image there, we do have lasers built into the tool, so it helps with that, so you're not having to actually throw string underneath the car. There's no option for wheel-mounted lasers because they have nothing to point at. The crossbars are not long enough to go outside a car, so you still have to use the lasers underneath the car. And if we're talking about that Volkswagen where we're calibrating that radar sensor up at the front, you have to do multiple positions because the mirror mounts in the center of that tool, and you have to move the whole tool into three separate positions. So we talked about there's two major requirements you have to have. You have to have some sort of scan tool diagnostics, and you have to have something to hold the frame. Well, when it comes to the diagnostic side, this will work on any of the Phoenix line tools. And I've been playing with the different tools and adding ADOS to them. And it does not, I've confirmed, it does not take up any more memory. It's actually just an activation. It turns on, boom, you're programming. You don't need to download anything else. Everything is already built into the tool, and you're up and running. So it is going to be something that can be added on to any tool in the Phoenix lineup. So if they already have a Phoenix Plus, they already have a Pro, they already have a Phoenix Lite, it doesn't matter. They can the ADOS calibration frame that they get with their Topdon set comes with that card already in it. They open that card, they type it into the tool, and they're up and running. They're ready to calibrate. A couple of things of note on this system. It is heavy. The way it ships, it's over 450 pounds because it's very well crated. It's very well foamed in. So when we ship this out, it's going to need a lift gate or a forklift to get it off of that truck. It's about a 4x4 pallet. Comes in a big coffin. It's about 2 foot tall, and then boxes will stack on top of that. We also have add-on accessories that I personally haven't put together yet, so I'm trying to put that kit together to be able to give us the most competitive options when it comes to the kits in the industry.